All right, today we're diving into a really fascinating study from the journal Obesity. It tackles a pretty radical question when it comes to weight loss. What if, instead of just focusing on the body, we could treat obesity by targeting the brain itself? This analysis is all about a head-to-head comparison between a new brain stimulation technique and two very common medications. So let's break it down. So here's the central question, and it's a big one. Is it really possible that just 15 sessions of a non-invasive therapy, all done within about 5 weeks, could actually produce a whole year of sustained weight loss? I mean, think about that. It's an idea that really turns the conventional long-term approach to weight management on its head. Now, to really get why these treatments are so interesting, we first have to understand the problem they're trying to solve. For many people with obesity and type 2 diabetes, the issue is what researchers call dysfunctional eating behavior. And what's happening in the brain is kind of a double whammy. On one hand, food cues make the brain's reward centers light up like crazy. But at the exact same time, the prefrontal cortex, the part that's supposed to handle impulse control, actually becomes less active. It's this imbalance that these brain-focused therapies are designed to fix. Okay, so this study was a retrospective analysis, meaning it looked back at data from 107 patients who were divided into 3 different treatment groups. The first group was taking what are called SGLT2 inhibitors. These are daily pills that basically help your body get rid of excess sugar through urine. The second group was on semaglutide. You've probably heard of it. It's a weekly injection that works on appetite signals. And then you have the third group, which received the novel treatment, repetitive transcranial magnetic stimulation, or RTMS. This is the non-invasive one, using magnetic pulses to stimulate specific parts of the brain over 15 sessions. All right, now for the main event, the results. What we're looking at here is a chart that tracks the average body weight for patients in all 3 groups over a full year. And let me tell you, even at a quick glance, it's pretty clear that these 3 treatments tell very, very different stories over those 12 months. So after that full year, what did the final numbers look like? Well, they're pretty striking. The group that received RTMS lost an average of 8.2 kilograms. The semaglutide group, they lost an average of 5.7 kilograms. And the SGLT2 inhibitor group, just 2.0 kilograms on average. I mean, that's a huge difference. The brain stimulation group lost more than 4 times as much weight. It's really quite stark. Okay, so what does the statistical analysis say about all this? Here's the key takeaway. The weight loss between the RTMS group and the semaglutide group wasn't actually different enough to be statistically significant. But, and this is a big but, both of them were significantly better than the SGLT2 inhibitors. This is a really important finding because it puts this non-invasive brain stimulation right up there on a similar level of effectiveness as a major weight loss drug. Let's take a closer look at that SGLT2 inhibitor group because their journey is really interesting. For the first 6 months, things look pretty good. They lose almost 3 kilograms. But after that 6-month mark, something changes. The trend completely reverses and they start to regain the weight they lost. By the end of the year, they're left with a net loss of only 2 kilograms. We really need to understand why this rebound happened. So what's behind that weight regain? The researchers point to something called compensatory hyperphagia. That's a mouthful, but the concept is pretty simple. Essentially, while the drug is forcing the body to excrete calories via urine, the brain doesn't just sit back and let it happen. It fights back. It starts ramping up appetite signals to make up for the lost energy, and that ultimately undermines the weight loss in the long run. And that brings us to the million-dollar question, right? Why did RTMS and semaglutide work so much better? Why did they produce not only more weight loss, but also weight loss that actually lasted? Well, the answer seems to be that they both share a common target. So what is that common target? It's the brain's reward circuit. Both of these successful treatments go straight to the source. Semaglutide works through pharmacology. You can think of it as directly acting on different brain regions to put the brakes on food intake and reduce those reward-seeking behaviors. RTMS, on the other hand, works through physics. It uses those magnetic pulses to essentially strengthen the prefrontal cortex, which is like the CEO of your brain's impulse control. This gives you more top-down control over eating behavior and food craving. You know, maybe the most incredible part of this whole story is how long the RTMS effects lasted. I mean, 5 weeks of treatment leading to a year of benefits, how does that even work? The most likely explanation is a concept called neuroplasticity. This is the brain's amazing ability to change and reorganize itself. So the stimulation isn't just a temporary boost. It appears to be inducing long-term physical changes in the brain's wiring, effectively recalibrating the very circuits that control eating behavior. So where do we go from here? What are the real-world implications of these findings? The study authors lay out a couple of really exciting possibilities. First, for patients who either can't tolerate the side effects of medication or just prefer a non-drug approach, RTMS could be a powerful alternative. And second, think about combination therapy. You could potentially use RTMS alongside drugs like GLP-1s to get a synergistic effect, tackling the problem from both a neurological and a hormonal angle to boost and maintain weight loss. Now, of course, every study has its limitations, and it's important we talk about them to keep things in perspective. First off, this was a retrospective study, not a randomized controlled trial, which is the gold standard. A really crucial point is that the dose of semaglutide used here, 0.5 milligrams, is lower than the maximum dose approved for obesity. So we're not seeing these treatments compared at their absolute maximum potential. And finally, there were some baseline differences between the groups, particularly in their blood sugar levels. All right, let's boil this all down to the key take-home messages. First, RTMS, a non-invasive brain stimulation, offers durable weight loss that's comparable to low-dose semaglutide and much better than SGLT2 inhibitors. Second, this isn't just a temporary fix. Brain stimulation can create lasting neuroplastic changes that support weight management for the long haul. Third, this really hammers home the point that the brain's reward circuitry is a critical target if we want to effectively treat obesity. And finally, all this points to RTMS as a really promising option, either as an alternative or as an add-on therapy for obesity and type 2 diabetes. So that leaves us with one final crucial question. What's the next step to validate brain stimulation as a mainstream treatment for obesity? Well, while these results are incredibly exciting, the clear answer is that we need a large-scale, prospective, randomized controlled trial. That's the gold standard. A study like that would be the final piece of the puzzle to confirm these findings and could potentially establish brain stimulation as a whole new pillar in how we treat obesity.